Okay, this is Math 261. This is section 12.4. And this is part 5 of the videos for that section. And this is another problem to find a unit tangent vector to the curve at a specified value, r of t. It's so dark. It's only 2:24 in the afternoon. It's Wednesday afternoon, and the power's gone out. Maybe it's gone out on campus too, in which case you'll be watching this in the future and maybe you'll remember. I hear it's out in other parts of town at least. So anyway, I'm going to keep pressing on here until my computer dies, which will be a little while. So anyway, r of t is given to us. R of t equals 8ti minus ln of tj. A value of t is given to us, which in this case happens to be t equals the number e. And we're supposed to find the unit tangent vector at that particular value of the parameter, meaning at t equals e. So there's a formula for capital T. Oh, and if you hear a beeping in the background, that's also related to the power being out. There's nothing I can do about that. So there's a formula for capital T of t, and here it is. Capital T of t equals r prime of t divided by the magnitude of r prime of t. And so we need to figure out r prime of t. R of t is 8ti, so the derivative of 8t is 8i. Minus ln of t times j, the derivative of ln of t is 1 over t times j. Alright, so we need to take that step there. To reiterate something that I mentioned in the previous part, though we absolutely 100% need to do that, what we don't need to do, we save ourselves just a little bit of work by being aware of this. We don't need to come up with a general formula for this. We did need to figure out this for sure. But now we can plug in the specific number, e in this case. R prime of e equals 8i minus 1 over ej. And then we can figure out the magnitude of this specific vector, r prime of e, instead of coming up with a general formula for r prime of t's magnitude. And the magnitude of r prime of e would be the magnitude of 8i minus 1 over ej, which would be equal to 8 squared plus 1 over e squared, all square rooted. So I got a common denominator of e squared there, so I put e squared over itself. And then this would be 64e squared plus 1 divided by e squared, and all that square rooted. That's equal to the square root of 64e squared plus 1 over e, because the square root of e squared in the denominator is e. Alright, now we have what we need to write down the answer. So we have r prime of e is equal to this, divided by the magnitude of r prime of e, which is equal to this. Now this one we want to simplify a little bit, and it's maybe a little bit tricky to do so. This is over 1, so it's like a complex fraction type of deal where there's an a over b over c over d, and you keep change flip. So you have 8i minus, I'm not going to have room there, I'm going to come down here. equals, you have 8I minus 1 over E J over 1, so I won't write that, times, this is the keep change flip part, E over the square root of 64 E squared plus 1. And then you can do is bring that constant, because this whole thing is a constant if you think about it, E is a number, you can bring that into each term. So you'd end up with 8 times E over that square root times I. Now in the second term here, there's 1 over E, and that E in the denominator will cancel with this E in the numerator, so that'll leave you with minus 1 over the square root of 64 E squared plus 1 J for the answer.